Welcome back everyone. My name is M. Ganesh Mani, USN 1VE 22EC 056, studying my engineering at Sri Venkateswara College of Engineering in ECE stream. So the course name for today's video is Network Analysis and the course code is VEC 304. So today's topic that we are going to be looking is superposition theorem. So this is one of the theorem in the module 3 of network analysis where the superposition law is imposed while solving the problems. So superposition theorem. This theorem is applied in two multi-source network. Statement. It states that in any linear bilateral multi-source network, the response in any branch is causal to algebraic sum of responses obtained by considering each source acting separately by making all other sources set equal to zero. The voltage source are made zero by shorting the circuit and the current source is made zero by opening the circuit. So next we'll be looking into the proof after the statement. So this is the proof. Consider the network as shown. So as we can see, there is a voltage source connected to three resistance as Z1, Z2, Z3 and a current source which is in opposite direction to the voltage source. And there is a current, we need to find the current flowing, that is Ix. So consider the network as shown. Apply the KVL in loop 1. As we can see, there are two loops. First would be the loop where Z1 and Z2 and voltage source is present, that is I1, and Z2, Z3 and current source is present, that will consider the loop 2, that is I2. So apply KVL in loop 1. So as we can see, that is Z1 I1 plus Z2 I1 minus I2, as Z2 belongs to both loop 1 and loop 2. So the current flows is both I1 and I2 from opposite direction. So we are considering the loop 1, so we need to consider the first current, that is I1 as first, and then only we'll be going into I2 as the next. So which is equal to V, that is a voltage source. So by solving that, we'll obtain the equation of I1 as V plus I2 Z2 divided by Z1 plus Z2. We note that I2 is equals to I. So let us find the KVL in loop 2. So Ix is equals to, so the loop 2 is belongs to I2 is equals to I. So we know that. So that is the reason the current flowing through Z2 is also I. So we need to find what is the current flowing through Z2, that is Ix. So Ix is equals to I1 minus I2. So V plus I Z2 divided by Z1 plus Z2 minus I. So this will be simplifying by taking the LCM. So further it Z2I and Z2I will get cancelled and we'll be obtaining the equation, that is Ix is equals to V minus Z1I divided by Z1 plus Z2. So this is how we can obtain the value of Ix. But that's only the first part. The second part includes the verification of superposition theorem, where we'll be undergoing three cases. So this is one of the first case, that is consider voltage source and set current source to 0. So as we mentioned in the statement that we need to make 0 of one of the source in order to consider the other source, and then we need to make the voltage source as 0 in order to consider the current source. So in this we'll be open circuiting the current source, that is I is equals to V by Z1 plus Z2. So the second case is consider the current source to make voltage source 0. So by making the short circuit in the side of current source by joining both the lines, we can see that we have closed it and we have short circuited it. So this is how we can make the voltage source at 0, and using the current division rule, I dash is equals to Z1 divided by Z1 plus Z2 minus I. So further we'll be getting both I double dash and I dash. So once we add both of them, we'll be getting the same result of Ix, which is equal to V minus Z1I divided by Z1 plus Z2. So this both equation should be equal, then only we can come to the conclusion that the superposition theorem is verified, which means in problems both the answers must be same, then only we can conclude that superposition has been satisfied. And therefore by case 2, case 3, case 1 and by getting the previous stage also, we can state here that the superposition theorem is proved. So now let us take a look on the problems of superposition theorem. So this is one of the example of superposition theorem. So where the question is, so as we can see, this is one of the problem, that is find the current flowing through 20 ohms resistor using the superposition theorem. So there are four resistors, that is 5 ohm resistor, two 10 ohm resistor and one 20 ohm resistor. And there are two sources. One is a voltage source of 20 volt and a current source of 4 amps. So first we need to verify by using the KVL method of loop analysis, and then this is the verification method, which is first let us find out the current flowing through the circuit by considering only the 20 volt source and by open circuiting the other source. So as we have open circuited it, so there is no flow of current in that, so it would be only the 20 ohm source and two 10 ohm resistor, one 5 ohm and one 20 ohm. So in this we need to find out what is the value of current. So we'll be using the nodal analysis method. By the nodal equation we can find out that V1 minus 20 by 5, V1 by 10 and V1 by 10 plus 20, which is equal to 0. And further taking, we'll get the value of V1, which is equal to 12 volt, and I1 is equal to V1 divided by 10 plus 20, and 12 volt divided by 30 would give us I1 is equals to 0.4 amps. So now we'll be looking into the third step, which is short circuiting the voltage source and making it to zero and considering only the current source, which is 4 amps. So we'll be first solving out all the resistors into one parallel resistors to the current source so that we can easily find it. So we'll be looking it into the format, that is the 5 ohm, 10 ohms and 10 ohms. These are the three resistance first which we need to consider it. So as we can see that 5 ohm and 10 ohm are connected in parallel combination, which is 5 into 10 divided by 5 plus 10, and further it is connected in series with another 10 ohm resistor. So by solving this, we'll be getting the value of resistors as 40 by 3 ohms, and then we'll be finding out this value of current, which is equal to 1.6 in the flow of 20 ohms by considering the voltage source, and the total current would be I1 plus I2. So as we can see that I is equals to 0.4 and 1.6 is the second value of current, that is I2. So by summing up we'll get 2 amps. Therefore the current flowing through the resistor is 2 ampere. So thank you everyone. Thanks for watching this video. Please do like, share and subscribe to my channel. Hit the bell icon for the latest notification. Share all your views and comments in the comment section below. Stay tuned for more upcoming videos. Goodbye.